Since we already covered multiplication, the very next stop is division. It always goes in order. So if you can explain division with rational numbers, with fractions, in a way where you link it back to something the students already know, that's always a recipe for success. It makes it easier to learn new things if you can tie them into old things. So let's talk about division of whole numbers. When we did division before, 10 divided by 5, one way that you can think of that is, well, how many 5s are inside of 10? If you think about it, well, how many 5s are inside of 10? I mean, you have 10 fingers on each hand, right? Or 5 fingers on each hand, that's 10. How many 5s are in 10 is 2, right? And usually the answer is smaller than the number you start with, right? 10 divided by 5 is 2, or 10 divided by 2 would be 5, so you always get a number that's smaller. But if we use the same concept, we could say that 3 divided by a half, not 3 divided in half, but 3 divided by 1/2. That would mean how many halves are in 3. If we're going to use the same logic, right? How many of the second number fit inside the first number? Well, I don't know. Let's see. Let's take 3 wholes that we have here, and maybe let's cut those into halves. So cut 3 into halves. Why are we cutting into halves? Because they brought up the 1/2 here. Well, let's count. How many halves are there inside of 3? 1, 2, 3, 4, 5, 6. There are 6 halves in 3. So that means 3 divided by 1/2 equals 6. And this blows students' minds. They don't like it at all because when you did division before, the answer was generally smaller than the first number. Now 3 divided by a half, we get an answer that's bigger. And that doesn't feel right. It doesn't feel like division. So you've got to have a way to model this to prove to students that no, it is actually 6. So one way to do it is to draw a picture like this. You can also do it using a number line. So before we did, for 10 divided by 5, we said, okay, we're going to start at 10. How many times can I subtract 5 from 10? So if you think about being on a number line at 10, you can subtract 5 and subtract 5 again before you get to 0. So it would be 2 jumps, right? 2 times is how many times you can subtract 5 from 10. So we're going to use the same logic. For 3 divided by a half, you're going to say, how many times can I subtract a half from 3? So you think of it as a number line. Here's a number line. We want to start at 3 and subtract a half until we get to 0. So I guess I better cut all of these into halves. And I'm going to start at 3. Use a different color for this. Start at 3. And I'm going to subtract a half. Subtract a half. A half. A half. A half. A half. We're going this direction every time, and it's minus a half, all the way down the line. How many times can we subtract a half? Well, 1, 2, 3, 4, 5, 6. 6 times, or 6 jumps. But the answer is 6. So 3, if you repeatedly subtract a half, you can do it 6 times. So that's how you would do it as repeated subtraction. Again, tying into something that they already know. Well, if you think back to subtraction, the official definition for subtraction was adding the opposite. So they actually defined subtraction as addition. Why would they do that? Why would they make it addition? Well, because addition is easier inherently than subtraction. So one of the ways they told us to think about subtraction is, in the textbook, they said A minus B, you would just change it to adding the opposite, or the additive inverse. What would you add to get 0? So adding the opposite. So it should be no surprise that they're going to define division as multiplication. Why? Because multiplication's easier. So we're going to use the multiplicative inverse. What is the multiplicative inverse? That is the reciprocal. So A divided by B, if you think of B as B over 1, we're going to change it to multiplying the reciprocal. So dividing is multiplying by the reciprocal, or multiplying by the multiplicative inverse. So this is huge. So division algorithm for rational numbers is if a over b and c over d are any rational numbers, and we don't want this c over d to be 0, okay, then if you take a fraction and you divide by another fraction, what you do is you keep the first fraction the same. See, a over b stays a over b. So this one you keep. You're going to flip the second fraction, and you're going to change to multiplication. So some of you may have learned the phrase keep, flip, change, or keep, change, flip. Maybe we can do it that way. Whichever way you want to think about it is fine. So we keep the first fraction, we change to multiplication, we flip the second fraction. Okay, keep, change, flip, keep, flip, change. I know it's whatever. It's all the same thing. Keep the first one, change to multiplication, flip the second one. That's how you divide fractions. So let's just practice a couple. So 1/3 divided by 3/4. We don't want to think of it as subtracting on a number line would be a nightmare with thirds and fourths. So what we're going to do is we're going to flip this guy. And we're going to change to multiplication. So we kept the 1/3, changed to multiplication, flipped the second guy to 4/3, and then you can just multiply straight across the top and straight across the bottom, and you'll get 4/9. If you have mixed numbers, this is one time I would actually suggest that you change them to improper and you do the keep, flip, change, keep, change, flip. So 3 1/4 would be, what's that, multiply that add, so 12, 13/4. And we're wanting to divide that by 8, 9, 10, 11/4, right? So change them to improper first. And then we're going to keep the first one, change to multiplication, flip the second one, right? This one gets flipped. And what you're going to notice here is that you have a 4 on the bottom that's going to cancel with a 4 on the top. And you'll just get 13/11. Now if you wanted to write that back as a mixed number, 11 goes into 13 once. And there's a remainder of 2, so 2/11. So either one of those answers would be fine. You really just need to see like what the instructions on the problem say, if they want you to leave the answer as a mixed number or if they want you to write it as an improper fraction. So the instructions usually will tell you. So that's how you divide fractions. No common denominator, keep, flip, change, right? Let's try one word problem. We've got 15.5 yards of material available to make towels. Each towel requires 3/8 of a yard of material. So 3/8 of a yard is how much one towel takes, and we have 15.5 yards of material total. How many towels can be made and how much material will remain? So they're asking you for two things: the number of towels and the amount of material. That's towels and yards. It's two different things. So we need to have a conversation as we go through this about what all these numbers stand for. So essentially we have 15.5 yards of material and we want to divide it into a whole bunch of towels. So we're going to take 15.5 and we're going to divide it by 3/8. That's where we're starting. It's going to be a division problem. So the first thing I'm going to do is I don't want to use a mixed number. So I'm going to call that 31/2. And we want to divide it by 3/8, right? So we always flip the second fraction around. This is the one that's going to get flipped. And we're going to change to multiplication. So 31/2 times 8/3 once we flip. And that's going to be 31 times 8. Any little calculator will tell you it's 248 divided by 6. And 248 is even, so is 6. So if I divide each of those by 2, 248 divided by 2 is 124. That's kind of an easy one to do in your head. Just divide each number by 2, and then divide 6 by 2. We get 124 divided by 3. That is the number of towels. But you're probably not going to tell somebody, go make 124 thirds towels, right? Like, how do they make a third of a towel? That doesn't make sense. So we need to convert this back to mixed numbers because it makes more sense. So we're going to have to divide this. So I'm going to take 124 and I'm going to divide by 3. And I'm just going to use long division to do this. Does 3 divide into 1? No. But 3 divides into 12. It'll go in there 4 times. 4 times 3 is 12. Carry down the 4. 3 will divide into 4 one time. 1 times 3 is 3. We have a 1 left over, but remember you take the remainder here and you put it over this divisor. So that's 1/3. 124 divided by 3, this is the number of towels. You can make, I can't write and talk at the same time. There we go. You can make 41 1/3 towels. So how many towels can be made? 41. How much material is left? It's not 1/3 of a yard, it's 1/3 of a towel. So 41 towels can be made with 1/3 of a towel left. So the first answer, how many towels? 41. But what we have to figure out is this, what is 1/3 of a towel? How many yards would that be? Because I want to know how much material is left. We have enough material for 1/3 of a towel. 1/3 of, how much is a towel? 3/8 yard. 1/3 of a towel. Well, when you multiply those, do you see the 3's will cancel? And this will leave you with 1/8 yards of fabric left. Enough fabric for 1/3 of a towel. And what is 1/3 of a towel? It's 1/8 of a yard of fabric. So this is what I mean by it's extremely important as you're working the problem to pay attention to what the numbers mean. This is not, the whole number is not towels and the fraction is not yards. It's all towels. It's 41 towels and 1/3 of a towel. It was your job to figure out how many yards at the end. So you just have to be careful on these problems. Sometimes they're a little deeper than you think they're going to be when you read them.